Welcome to our video. My name is Ana Cristina Bañuelos Lara and my team's Luciana Contreras Dávila and Nina Sofia Monge Ramirez. And today we will be presenting about parallel and series circuits. But first of all, what are some applications of parallel circuits? They are used for the wiring system of houses, the internal circuits of a washing machine. They are used in infrastructure to supply power to large population. They are also used in lamps with several bulbs lit at the same time, and the computer hardware is designed using parallel circuits. Some other applications of series circuits include light switch, lamps, and water heaters.
Okay, so now we're going to see an example of a series circuit. We need to create a circuit with the following data, but in order to create it, we're missing the resistance of each light bulb. So in order to find it, first we need to use the Ohm's law, which says that the current flowing through a given conductor is directly proportional to the potential difference between its end. So this basically is expressed by V equals current times resistance. So then we're going to solve for the resistance, and it's going to be voltage divided by current. But we don't have the current, so to find it, we're going to use the data that the picture is giving us in the formula of power, which sets the current times voltage. So then we're going to solve for current, and it's going to be power divided by voltage. So it's going to be 8 watts divided by 12, and it's going to give us 2/3 amps. Now that we have the current, we can use the formula from the beginning. Voltage divided by current. So 12 volts divided by 2/3 amps is going to give us 18 ohms. Now that we have the resistance, we can create the circuit. Now, we're going to use a tool called the voltmeter in order to find the voltage from the circuit. Here in the picture is telling us that the voltage is 27, as on the battery the same that is 27. Now, we're going to use the Kirchhoff voltage law in order to find the voltage from the light bulb. So in here the voltmeter is telling us that the voltage of the light bulb is 9 volts. But how can we prove it? Well, with this law, which says that the sum of voltage around any closed loop is 0. So we're going to use 27 minus the voltage resistance number 1, which is the light bulb, minus the voltage resistor number 2 minus the voltage resistor number 3 is going to give us 0. Then we divide 27 divided by 3 and it's going to give us 9. So we can prove that here we're using the Kirchhoff's voltage law. And the voltage from each light bulb is 9 volts. Now we're going to use another tool that is called the ammeter in order to find the current from the series. So in here the picture is telling us that the current is 0.50 amps. But how can we prove it? Well, we can prove it with the Ohm's law. We solve for current is going to give us voltage divided by resistance. But this time we're going to use the voltage from the circuit, which is 27, and the equivalent resistance, which we find it by adding the 3 resistance from the light bulbs, and it's going to be 54. And the answer is 0.5 amps, the same as the one that the picture is telling us. So at the end we have the following data. The voltage of the series circuit is 27 volts, the current is 0.5 amps, and the equivalent resistance, as we mentioned, is 54 ohms.
So now we're up to the second experiment with a parallel circuit with 3 light bulbs and a battery of 24 volts. So if we wanted to know the current going from these loops here, we will use Kirchhoff's current law, but we don't want to know that yet. So for knowing the current going from each of the light bulbs, we need to know, we use the formula power divided by voltage. So the problem already gives us voltage and power, so we know that 10 watts divided by 12 volts equals to 5 divided by 6 amperes, or 0.83 amps. So now that we got a current in each light bulb, we need to know the resistance in each light bulb. So for resistance, we do voltage divided by current. That is 12 volts from the ones here divided by the result here. That is 5 divided by 6 amps or 0.83 amps. And that gives us 14.4 ohms. So now that we got the resistance in each light bulb, well, all are the same. So we do 1 divided by 14.4 multiplied by 3, or just plus 3 times, and all these up to the minus 1, and this gives us 4.8 ohms. That is the equal resistance. So for the current in the circuit, we do voltage divided by resistance. So voltage, we use the one from the battery, that's 24 volts, and resistance, we use the equal resistance. And 24 divided by 4.8 ohms gives us 5 amperes. That is close enough with the current keeps us from the meter. That is 4.97 amps. So in summary, the circuit is parallel. The voltage from the battery is 24 volts. The current is 5 amperes because we know that because we got it here. And the equivalent resistance is 4.8 ohms.
Now, as we previously saw an experiment, right now we will see how the results needed to be in theory. As you can see here, the equivalent resistance was got with the formula of the division between the voltage and the current, which the voltage was taken from the battery, which was 27 volts, divided by the 0.5 amperes, which gave a resistance of 54 ohms. Now, going to the total current, we got that it was the division between the voltage divided by the resistance that we previously got, which was 27 volts and 54 ohms, and that gave a total current of 0.5 amperes. Now, when we move to the parallel, we have the equivalent resistance that we got its 4.8 ohms using this formula, and the total current was 5 amperes using the formula of the division of the voltage divided by the resistance. As you can see, the results did match with the previous experiment, and also these calculations were made to have a background and to see if the results were right. Now we're going to see another very interesting thing, that is how are Christmas lights connected. The basic ways is in series circuit. They are also semi-parallel, but they are mostly in series circuit. They are wired in a series from the first up to the last light. The path of the electric current is flowing through the circuit from the source back to a single wire. Current is passed to each light bulb when the light provides a resistance when the voltage is getting applied. The currents get out the filaments of the light bulbs, and that release photons and produce the light. If some resistors are working on a circuit and the others are disconnected, this is an example of a parallel circuit. And if the voltage drop in a circuit is the same in each resistor that can form it, the resistors are also connected in a parallel way. Finally, how does equivalent resistance of a parallel circuit compare to individual resistances in the circuit? They get to a total resistance that is less than the smallest of the individual resistances. Thank you so much. We hope that you like our experiment and our work.